Today we're going to learn about SAT math. And our topic is geometry, formulas. In this topic we'll learn a variety of different types of equations that may come in handy on the SAT exam. So let's get started with a couple of simple formulas that you may know already. So the first formula we're going to learn is the volume of a sphere with the radius r. So volume is equal to 4/3 pi r cubed. This equation helps give us the volume of a sphere if we are given the value of r. So volume of a sphere. So let's say we're given a radius of 2 inches, and we're told to find the volume of a sphere. So using this equation, we would do volume is equal to 4/3 times pi times 2 cubed. And this gives us 4/3 times pi times 8, because 2 cubed is 8. Simplifying this, we get 32/3 pi inches cubed, because we need to show our units. So this is our answer to that question. Now let's go on to another equation. So our next equation is the sum of angles of any shape. So that equation is sum of angles is equal to n minus 2 times 180, where n is the number of sides. So what this gives you is the sum of the internal angles of any shape. So let's take a couple examples that we already know. So let's take a triangle, and we want to know the sum of the internal angles. So what we would do is we'd count the number of sides we have. We have 1, 2, 3 sides. Using this equation, we would do 3 minus 2 times 180, which is just 1 times 180. And that gives us 180 degrees. So using this equation, we can find the number of the sum of the angles, the sum of the internal angles of any shape. The next important equation that could come in handy on the SAT is the midpoint equation. So, for example, we're given 2 points where A is equal to x1, y1, and B is equal to x2, y2. And we want to know the middle of this line. So let's take a graph. So that is A, and that is B. And we want to know the exact middle point on this on the imaginary line that could be drawn from A to C. So to do this, we have an equation called the midpoint formula. And this is M is equal to x midpoint, y midpoint. And this is equal to x1 plus x2 over 2, y1 plus y2 over 2. And when solving this out, we find the midpoint of the middle of between the 2 points. So let's try an example with this. For example, we have a plane like this, and we have points 1, 2, and point 5, 8. We want to know the midpoint between these two. So what we would do is, we would take the x1 and the x2 and add them together. x1 plus x2 is over 2. Then divide by 2. Let me clean that up a little. 5, comma, then we add the y midpoints. 2 plus 8 over 2. And when we solve this out, we get 3, comma, 5. And that is how we find the midpoint of two given points. Now let's go on to another equation that could come in handy. And this equation is called the number of diagonals in a given shape or any polygon. So this formula is diagonals is equal to n times n minus 3 over 2, where n is the number of sides of the shape. So let's take an example. So let's say we have a square. We want to count the number of diagonals from each number of diagonals in the total shape. So we know that there are 1, that's 2. But what if we have a more complex shape? Well, we can use this formula and to help us out. So, using the formula, we know we have 4 shapes in a square. 4 sides in a square. So it'd be 4 times 4 minus 3 over 2. And when we solve this out, we get 4 times 1 over 2, which gives us 2. So we know we have 2 diagonals in a square. So our next formula it's called the distance formula. And what this does is it gives us the distance between 2 points, 2 given points. So let's do an example. So for example, we have point A and point B. Point A is equal to x1, comma, y1. Point B is equal to x2, comma, y2. That's A and that's B. And we want to know the distance between these two. What we can do is we can use a formula called the distance formula. And what this is, it's written as this. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? Using this formula, we can find the distance between 2 points right here. Alright, now let's do an example. So let's say we have 1, 2 and 5, 6. Alright? And we want to know the distance between them. What we would do is then we used our equation. Distance is equal to the square root of. So we can do 5 minus 1 squared plus 6 minus 2 squared. Solving this out, we get distance is equal to the square root of 4 squared plus 4 squared, which is equal to 16 plus 16, which is equal to the square root of 32. So the distance between points A and B is the square root of 32. So right now, I want to quickly go over 2 types of special triangles. So let's say we have a triangle like this, and the angle measures are 45, 45, and 90. So this kind of special triangle states that, let's say this length right here is x units long. That means the angle right here, the side length here is also x inches long, x units long. Therefore, making this the square root of 2 times x inches long. This is a type of special triangle. So for example, you are given a triangle that's 45, 45, 90. And you're told that this is 5 inches long. This is 5 inches long. So how long is this side length? Well, since we know that this side length corresponds to this side length right here, we can write this as the 5 times the square root of 2 inches. Okay? So there's one more type of special triangle. So let's say we have a similar type of triangle, except this time this angle here is 30 degrees, this is 60 degrees, and this is 90 degrees. Well, the rule is that the 60 and 30 degree angle is, well, in this case we know that the 60 and 90 degree line gives us x. The 90-30 degree line gives us the square root of 2, 3 times x, and the 60-30, meaning the hypotenuse, is 2 times x. So let's take an example of a triangle like this. So this is 60 degrees, this is 30 degrees, and this is 90 degrees. Let's say we're given that this is 5, and we want to find this length and this length. So we know a rule that this side corresponds to this side. Therefore, this side corresponds to this side. That means that the 30 and 90 degree line gives us 5 times the square root of 3. And the 60-30 line, meaning the hypotenuse, gives us 10. So that's it for this video, and next time we'll learn something different. Not geometry formulas, but maybe something more fun. See you next time.